For those of you who have been following this channel for some time, you probably know that I have a great deal of belief in the concept of space-based solar power. I believe that this is the most efficient and productive and green way that we can gather the necessary energy to power our civilization, which frankly is becoming more and more hungry for energy by the day. However, for the longest time, it seemed that the People's Republic of China was really the only country that was seriously going after this objective. Yes, we've had some small-scale projects being carried out by a variety of companies and universities and other institutions across the planet, but it's the Chinese who have the most aggressive plan when it comes to putting a space-based solar power station up in a few years. By 2025, having a pilot plant up in orbit, and by 2050, having a full-fledged 1 gigawatt power plant in orbit, or perhaps sometime sooner than that. And that seemed to be the most aggressive plan that anybody was working on. Until now. Late last month, an even more aggressive solar power station plan was presented by the nation of Great Britain of all people. Not by NASA, not by Russia, not by countries that have a tradition of a huge amount of activity in space, even though the British certainly have accomplished a great deal when it comes to satellite technology and have a growing private space industry, but they are planning to put up the most aggressive solar power station ever planned in human history. We're talking about 3 gigawatts being beamed down from geosynchronous orbit by 2040, significantly more ambitious than the Chinese plan. Now, in all fairness, the video that you're watching right now has absolutely nothing to do with the United Kingdom. This is the United States Space Force and an incremental space solar power plan that they have that is far less ambitious, but based on the same principle of gathering solar energy in space, converting it into radio waves or microwaves, and transmitting that energy down to Earth. It's called the Arachne. But in any event, the principle is the same, just much, much bigger. So how the hell do the British really intend to get this accomplished? And why are they taking the lead when so many other countries who have so much more money have not done the same? Well, we're going to find all of that out in just a moment. Now I realize that I have viewers who fervently believe that the whole concept of global warming is a load of dingoes' kidneys, as somebody once wrote, and I am not here to try to argue this point with them. Perhaps global warming isn't something that's facing the human species. Perhaps we're not destroying our climate, and if that is the case, I certainly hope so. But in case it isn't, in case all of the pollution that we're pouring into the atmosphere is actually having a long-term impact on our environment, the United Kingdom seems very determined to do something about it. Their plan is to become net zero by 2050, meaning that they will put out as much carbon as they absorb, or rather save. But the problem with a lot of net zero plans or green energy sources is the fact that they tend to put out as many greenhouse gases as they tend to save. So, like solar panels, for example, require a great deal of manufacturing and mining, and so do wind farms. Virtually everything that we put here on the surface of the planet to save carbon is going to end up producing carbon in the process. But the Fraser Nash Consultancy, who recently put out a report that is sponsored and supported by the British government, has said that space-based solar power is the lowest risk path to net zero. Now, the British are big believers in solar power, which doesn't make a huge amount of sense given the fact that the sun doesn't shine there very much compared to this American power plant in Southern California, but nevertheless, the solar farms in the UK increased from 5.5 gigawatts in 2014 to 13.2 gigawatts in June of 2019, an unbelievable increase in green energy being generated by solar power. However, solar power has many drawbacks. For one thing, obviously the sun is not out all the time, and on top of that, there are cloudy days, especially in Britain. And the obvious advantage of a space-based solar power plant is the fact that as long as you put it in geosynchronous orbit, the sun is never going to go down. And not only that, sunlight doesn't have to pass through the atmosphere either, increasing the efficiency of solar panels by a factor of 4. So you're looking at quadruple the power for the same amount of surface area. However, it is a huge amount of difficulty trying to get that much in the way of solar panels out all the way to geosynchronous orbit. How the hell are you supposed to accomplish that? Well, first of all, let's look at the benefits that the plan brings to the United Kingdom and indeed to the world. First of all, they want to deliver net zero by 2050, establish the United Kingdom as a global environmental leader, secure critical infrastructure, and I'll get into that a little bit later, high technology growth and jobs. Obviously, a lot of jobs would be provided by something like this. Growing our space capability. Clearly, Britain would need a lot more space capability than they currently have to do this, and economic prosperity and leveling up. So let's have a look at these different advantages one by one. Now, the first thing to consider is, why is this type of energy superior to other types of green energy? Well, for one thing, it's continuous power generation, obviously, 24/7, 365 days a year. No cloudy days, no night, obviously, and obviously the sun is going continuously. You can also have security and resilience to political or terrorist action. If you put something all the way out in geosynchronous orbit, it's very difficult to take it down. It also provides long-term security of fuel supply because obviously the sun isn't going to be running out of fuel anytime soon. It's also readily integrated with existing grid infrastructure. It has low intermittency and high predictability, and that's something that green energy has a real problem with. Wind farms are not always predictable because the wind isn't always blowing. Conventional solar farms are not predictable because the sun isn't always shining. So there's a huge advantage as far as that's concerned as well. A fully sustainable renewable energy source, obviously, and a low environmental impact. That is to say, a footprint or land use, because you're establishing a massive solar farm in orbit. Whereas to build solar farms or wind farms, you have to consume a great amount of surface area on the planet, sometimes chopping down entire forests in order to build these things, which is sort of counterproductive. Much better to build these sorts of things in orbit. Now, there are other advantages as well. It's a lot more flexible. For example, the energy can be beamed to a different location on the surface of the planet if need be. If there there's a part of the planet that requires emergency energy, for example, then the necessary energy could be beamed to a different receiver on a different part of the planet without a great deal of time or complication, assuming, of course, that you had receivers everywhere across the planet, which would require a great deal of infrastructure. Now, there's a lot of other space-based infrastructure that's involved as well, so let's move on to that. A system of this kind would involve a solar power satellite, space launch and transportation to orbit, obviously, a ground antenna, including pilot beam and grid interface, and finally, power and satellite mission control. Now, the solar power satellite itself is undoubtedly the most challenging part of this project. It's a massive kilometer-scale spacecraft in geostationary Earth orbit in order to get constant sunlight and to beam that sunlight, or rather the power generated by it, down onto the same spot of the Earth at all times. The panels would generate over 3 gigawatts worth of electricity on the satellite. By the way, I know some people have told me that it's gigawatts, but you know what? I grew up in the age of Dr. Brown, so it's gigawatts, damn it. In any event, the energy is converted into high-frequency radio waves and beamed to a rectifying antenna, also called a rectenna on Earth. And this is termed wireless power transmission, or WPT, and the radio frequency proposed is between the 1 and 10 gigahertz atmospheric window, which makes it capable of beaming at full power regardless of the seasons and the weather. And by the way, that's straight off of the report. Now, the proposed power satellite is 1.7 kilometers in diameter and weighs about 2,000 tons. Now, there might be ways to bring down this mass if you were to use an origami type of solar collector. These sorts of things are already being experimented with. They consume a lot less mass and a lot less volume, so that might be a possibility. But nevertheless, let's just assume that it's going to be 2,000 metric tons. That in itself is a tremendous undertaking, getting 2,000 tons worth of mass all the way out to geosynchronous orbit. You can do it bit by bit, and it would be constructed by robot, but nevertheless, getting that much mass all the way out to geosynchronous orbit would be beyond difficult. A Vulcan Centaur, for example, can only get 7 metric tons out to GEO. That would be hundreds of Vulcan Centaurs and billions of dollars. You would have to have a different type of rocket or a different type of infrastructure, as I was talking about. And by the way, here's a demonstration of how the whole rectenna system would work. This would also consume a fair amount of space on the surface of the planet, but you wouldn't necessarily have to put it out in the countryside. You could actually put it out in the ocean if you wanted to. There would be lots of ways to configure this in order to integrate it into the existing power network. However, getting back to the rocket that you would need for a system like this, well, the solution is obvious. You would need Starship and its 100-ton capacity. Now, Starship cannot bring 100 tons all the way out to GEO. Instead, it needs to be refueled. So what you would probably need is a single Starship carrying out 100 tons worth of solar panels at a time, and then tanker Starships refueling it periodically in low Earth orbit. An infrastructure, as I was saying before, of Starships, tankers, and transport Starships to build something that would mass about 2,000 tons all the way out in GEO. Nevertheless, the Starship is something that could definitely accomplish this. 20 trips of the Starship plus all of the refueling flights. Granted, this would be a lot of refueling flights and a lot of operations on the part of SpaceX, but nevertheless, it would certainly come in within the 16 million pound budget that Britain has allocated for this particular project. Starship seems to be the best solution for all of this, but there are other solutions which I'll get into in just a moment. Now, some of the other advantages to space-based solar is the fact that you can use it to power other spacecraft throughout the solar system. If you were to use high-energy lasers, for example, configured into the solar array, you could use it to power solar sails. For example, the Breakthrough Starshot initiative, sending solar probes all the way out to Alpha Centauri. These sorts of things would become not only possible, but actually pretty easy if you had this kind of power at your disposal out in orbit. And by the way, if you're concerned about the microwaves generated by this thing frying anybody on the surface of the planet, or that it could be used for some kind of weapon, the design of the system limits the power delivered to the rectenna at 240 watts per square meter, or about 1/4 of the intensity of the sun at the equator. Definitely not something that would be dangerous to human life. The rectenna would be very large, as I said before, about 6.7 kilometers by 13 kilometers. However, this represents a power density of 29 watts per square meter, whereas traditional solar arrays are only 10 watts per square meter, which means you're getting triple the efficiency for the amount of space you're using for the rectenna on the planet. So everything about this system is just far more efficient than conventional solar, wind farms, or anything else, and it has a lot of other uses besides just providing green energy to the planet. Now, another possible infrastructure that could bring all of this about is to use the Vulcan Centaur upper stage as a space tug, and I've talked about this a number of times. Since it uses hydrogen and oxygen in the upper stage with its RL-10 engines, this can utilize fuel manufactured on the moon, which means it could also use raw materials on the moon. And the moon, coincidentally, has all of the raw materials that you need for solar panels. A lot of silicon, plus all of the metallic resources that you require to make solar panels are available in abundance at the lunar South Pole. And incidentally, by 2040, we're going to have the infrastructure that we need in place on the lunar South Pole to make all of this possible, assuming that Artemis goes to plan. So Artemis might not only help us get to Mars and explore the solar system, it might also help us to establish a new source of energy for the human race that never runs out. So here's the British plan in stages. Phase 1, between 2022 and 2026, they establish a rectenna design and other things that are going to be necessary on Earth to make this technology possible. Between 2027 and 2031, you demonstrate a 40 megawatt power generating system in low Earth orbit to transmit meaningful power from orbit to the Earth. And it would be a lot easier, obviously, to establish this sort of thing in low Earth orbit, and you don't need non-stop power if you're just creating a demonstrator. From 2032 to 2035, you would have a 500 megawatt demonstrator in operational orbit. So all the way out in GEO, you would have something generating half a gigawatt already. And then from 2036 to 2039, you would ramp up to a 3 gigawatt production prototype in operational orbit, which would produce the same amount of energy as a large nuclear reactor. The plan also advocates international collaboration, but this is where things get a little depressing. There are very few countries on Earth that are really aggressively pursuing this extremely efficient and sensible means of producing green energy. The Japanese have done it. As a matter of fact, they successfully demonstrated kilowatt scale wireless power in 2015. So they've already demonstrated that it can be done. The Chinese are obviously aggressively moving towards this goal. South Korea has some interest in it. The European Space Agency also has a small scale program, but significantly, the United States, Canada, and Australia, none of these nations have any sort of government-supported space-based solar programs whatsoever. Such short-sightedness. We're talking about the most efficient and sensible source of green energy in our solar system, the sun, and the most efficient way of gathering the power from the sun, and that is to gather it in space. Why is it left to the United Kingdom to take the lead for the Western world in developing this extremely important technology that not only generates important energy to fuel our hungry civilization, but also all of the jobs, all of the spin-off technologies, all of the benefits that can be gained from such a technology? This can be done, it can be done affordably, and it should be done on an international basis. But instead, the United Kingdom stands virtually alone, with perhaps collaboration from the Japanese, and that's just about it. And that, frankly, pisses me off. It's something that needs to change, and hopefully it will change soon if the United Kingdom takes the reins on this full bore and demonstrates to the world what is really possible if we exploit the limitless resources that are available to us out in space. If you like what I have to say, please subscribe to my channel and support me. There are many ways to do it. Have a look at the description. And as always, please follow me on Twitter. Thank you very much for watching, and stay angry about space!